absolutely love scientific notation. So here's the deal. To calculate the number of atoms in 22.4 liters of hydrogen gas, we have to take the number 2 and multiply it by 602. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Right? Did I sound tired at the end of that? Okay. So the first joy of scientific notation, probably the most important joy, is this. That's a lot less writing. A lot less writing. It literally means what it says. 6.02 times 10 to the 23rd. So you have to multiply by 10 23 times. And you know that just moves the decimal point 23 places. So if I have 6.02, 23 places, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. And then you put all the zeros in and you get the same number I have up there. Okay? So it is the same thing. Okay? It's just a lot more compact. Okay? It's a lot more narrow. Is everybody happy with that? Yeah. All right. Okay? The second joy is this. Let's see if I can erase. Sometimes I can, sometimes I can't. Okay, good. Okay. All right. The second joy is this. What's 2 times 6.02? Somebody raise their hand and tell me what it is. Yes, ma'am. 12.04. So I could do this math without writing these, stacking them on top of each other and doing the 2 times 0 to, what's the deal? No. Okay. So 2 times 0 times 0 times 0, I get 0, 0, 0, 0, 0, 0, 0. Much easier to just do that, correct? Much nicer. Okay? So another thing is this. If you look at how big the Sombrero Galaxy is, why is Sombrero Galaxy? This is my favorite. Versus the Milky Way Galaxy. If you look at those two numbers, which one's bigger? That's a lot of zeros. How are you going to figure out which one's bigger? Sombrero. Okay? If you look just below it, though, I wrote them both in scientific notation. Which one's bigger? Sombrero Galaxy. Okay? So it's handy for relative scale. The problem with relative scale is I can't write scientific notation this way, therefore. I must always put it, the decimal point 1 by the first number. Does that make sense? And I don't know what your name. What's your name? Yes. Last name? Oh man, Silva. Okay, I'm trying. Okay, so because I have to move it, I want to divide this by 10, correct? To get it to be right? So divide it by 10, but that means I changed the number, didn't I? Can't change the number, so if I'm going to divide by 10 to move it this way, I'm going to have to multiply by 10, which means 1 more times 10 to the right, which is times 10 to the 24th. Okay? So in other words, in order to make my 12 1.2, right, I have to divide by 10, which means to keep the number the same, and I have to multiply by 10 or add 1 to that. Okay? So that's one of the problems where scientific notation causes a little bit of a headache, because you always have to write it where it's 1 past the decimal point. Okay? All right, we've got a calculator on the desk, so I want you to just flip this over and try the problem on the back. Try the problem on the back. 230,000 times 1,000 times 4 with a whole bunch of zeros after it. not too bad if you got a calculator, right? You got an answer, it was written it down. Okay. Let me show you one last reason why scientific notation is better than normal notation, and then you're probably going to forget about it because you're going to have a calculator desk, so who cares? Okay. Now here's the last reason why old people, like me, like scientific notation. I'm going to write everything in scientific notation. So far, so good? Okay. Now, you know, because your math teacher beat this into you, that you can multiply in any order you want, right? So I'm going to multiply by doing 2.3 times 1 times 4 times 10 to the 5th times 10 to the 3rd times 10 to the 8th. It might not seem obvious why that's a good thing. But what's 2.3 times 1, everybody? 2.3. What's 2.3 times 4? 9.2. Times 10 to that. Hey, what do you do when you have 10 to the base is the same and you've exponents you're multiplying? Yeah, that's the exponent. What's 5 plus 3 plus 8?
16.
16. I'm done. Okay, so that's one of the joys of scientific notation. I'll tell you the truth, though. You're always going to have your calculator, so you're going to forget this. But that's probably what your 7th or 8th grade teacher tried to get you to see. All right, what do you have to be able to do? You have to be able to translate between the two. That's what you have to be able to do. So let me show you what that looks like. If I have 23,000, how do I write this in scientific notation? I'm going to want to pick somebody this time, and I don't have my little overhead. I can see that when I have the chart in front of me. I do. Miss Bonner, you hate being called. Okay, so I'm gonna. I don't have. I'm gonna ask you questions. You're just giving me answers. Is that okay with you?
Yeah.
All right. So I'm gonna go ahead and put a decimal point. So step one is I'm gonna go ahead and put a decimal point out there. Where does decimal point normally go?
Between the 2 and 3. Or no, behind all the zeros.
Behind all the zeros. So normally we go here, right? But we don't write it down because that's a lazy one. Why would you do that? Waste of time. Okay. But it can't stay there, right? Where's it got to end up?
Between the 2 and 3.
Behind the first number. In this case, between 2 and 3. So I'm going to go 1, 2, 3, 4. Good. And that's going to give me 2.3. How many places did I move it?
4.
4. That's how you write scientific notation. 1, 2, 3, 4. Is that okay?
Yeah.
Okay. Easy or is it easy? Okay. Then you're going to do the next one for me, almost without me helping you at all. Let's do this one. Here we go. Back to purple for a moment. I've got 2, 3, 0, 4, 1, 2, 3, 4, 5, 6, comma, comma, comma. All right. Tell me what I should do. Walk me through it so everybody else can follow along. What do you got? Or where do I put the decimal point first? At the end? Good. Got it? All right, let's do the other thing. What happens when they look like this? This time I'm going to pick on Mr. Pizka.
Would be 2.3 times.
You're answering too many questions. Just give me a second. Follow along. You with me? You got it? You already got the answers. You got this already. You're bored with it. Okay, good. Where's the decimal point? Right there. I have to give it to you in this case. Okay? By the way, I traditionally not put a 0 to the left of the decimal point. That's a holdover from when textbooks had a problem. They'd write, what if you had 0.02 and it was confusing because is that a period or not? So you put a 0 in front to say that wasn't a period. I think we're kind of over that now, but they don't. So we'll just go with it. All right. So what do I do?
Moved over.
Move over till I get
2.3.
behind the first number, right? Behind the first number. Now I went to the right instead of the left, and this is also a small number, so it's 2.3 times 10 to the negative, with the other way, we're dividing by tens now, and that means putting tens at the bottom, which is a negative exponent. 1, 2, 3, 4, 5. That makes sense? You guys got it? Remember this from middle school or wherever? No?
Yes.
Good? That kind of do, maybe? All right, let me pass out practice. We'll just beat you with some practice, and then we'll take care of it for you. Do not go past M, please. Do not go past M, please. M's on the bottom. Do not go past M.